Hello.
Welcome, everybody. Welcome,
Good
Alan.
morning, good afternoon, good night, good day.
Yes. How are you doing,
We're
Mr.
back.
Helton?
Doing all right, man. Doing all right. It's a nice, bright, sunshiny day here where I live.
Yeah.
What is it like where you live?
So you'll see I have a different angle today. It's not very nice today. It's super windy, and I'm in the desert, so dusty and sand all over. Internet's out, so I'm hotspotting. So if you see, that's why you have a different angle. I'm using my laptop camera and using my cellular phone's Wi-Fi or cellular connection. So
It's impressive. It's streaming. It's streaming. Looks good.
yeah, nice. So hopefully that keeps up. Hopefully I don't run out of juice. Well, yeah, hopefully I don't run out of juice on my laptop. But um, another exciting stream today. So I don't know if you saw it, Alan, but a couple of weeks I tried out Serverless Framework again. I hadn't played with it in a while. So built an API, all the fun stuff we like to do. And I wanted to get to the point of trying the Serverless Container Framework. And it was close to the end till I realized it's kind of a different setup, right? So it's not using the standard serverless YAML file, right? It's a completely different framework as per the name, but I didn't see that initially. So we are today going to be trying that. The idea was for me to type on my machine. But with the tragic set of events that are happening here at El Paso, someone else is going to be doing it. And I'll invite him to the stage. So today we have Austen Collins, CEO, co-founder of Serverless Inc. So I'm not sure his camera. Yeah, but yeah, here we are.
There we go.
So welcome, Austen. How are you doing?
What's up, guys? I'm doing well. Thanks for having me.
Yeah, so last week or 2 weeks ago, you saw me suffering online. You provided a lot of help and guidance and cool new things I did not know around Serverless Framework and the Serverless CLI and all that. So I really appreciate that.
Yeah. We I saw last minute you were using it and jumped on and tried to help where we could. But it's probably changed. When was the last time you used it before that time?
So yeah, it was probably V2 of the
Oh wow.
Serverless Framework. So yeah,
Yeah.
was my
That's like
Serverless Framework
2018.
knowledge. Yeah. So it had been a while, right? So I learned a lot a couple of weeks ago, and there's a lot that I didn't know it did, right? So I'm excited to now this Serverless Container Framework. I'm excited to see if it's as simple as it claims to be, right? Well, from flipping from Lambda function to ECS, right? And talk a little bit about the internals and all that. So I'm happy to have you here. Super excited.
Yeah, maybe I'll just jump in with some quick background, some context real quick. I'm Austen, CEO, founder over at Serverless Inc. Made the Serverless Framework way back in 2015, long time ago, and I've been working on that project for 10 years, a decade, which is a long time, and it's been a lot of changes, a lot of versions, throughout that. We launched V4 last year, and frankly, there's like a renaissance going on with that version in our company right now. All effort is just on the CLI, building the best CLI. We've gone from shipping, I think, once every 2 months to once a week now. And so there's just a bunch of new stuff in V4. So it's great when people are jumping into it, especially people who haven't used it for a long time, so they can see all the new stuff that's in there. And then as part of that, we wanted to, there's just all the effort in our company on the CLI right now. And we're doing great work in the OG serverless framework, but there's so much stuff, so many like problems, new problems that we've been wanting to solve forever that we just haven't had the time to get to until now. And one of the biggest problems was the serverless pricing memes that we've seen over the last couple of years. It's pretty much everywhere you go, people are saying serverless is expensive, and it's just gotten so bad. I think there's just a bunch of AI bots on like Twitter now that constantly just repeat this, and it's tragic. It was really tragic at our company because it was the classic like let's throw the baby out with the bathwater situation, right?
Yeah.
Where we have this incredible, these incredible cloud computing services where we spin up infinite logic and it doesn't charge you anything until a user actually interacts with it. And then when they do use it, it charges you a fraction of a cent, right? I mean, that is like the greatest efficiency of all time, and like ultimate empowerment if you're a builder. But then just to go and say like, but it could be too expensive, therefore we shouldn't use it at all, and we should revert back to something totally different. That was just one of those times in history where I was like, what why would we get rid of all this and not use this incredible power? And I guess the most frustrating part was that nobody was providing a simple solution to basically offer flexibility, because you can get to market really quickly with serverless. You can prototype really quickly with serverless. It's great. You can deploy, get something in the cloud really quickly, show it to people, hit that viral moment, scale up to millions of users like that. But no one ever finished the story as to what you do after that. Like what happens when you have all these high volume Lambda functions? Because, well, the serverless pricing meme in that case is actually true, right? It is way more expensive, when you have those consistent high volume Lambda functions, and nobody was really addressing that. And that was like it's just a missing piece of the serverless story. So in some sense, it was like, it's frustrating to see us, people totally want to revert from serverless without trying to solve this problem. And we especially have it with our customers because we've been around for so long that we've had so many customers that have gone from prototype all the way through acquisition or IPO. And they have tons of high volume Lambda functions that are pretty expensive. And so we needed to solve this for our customers. We wanted to solve this just for the sake of serverless movement. We needed something that just finished that serverless story. And that is like, well, let's give people flexibility. So once they get through all that and they have those high volume Lambda functions, let's just let them easily move stuff around, without having to re-architect. Like that's the big problem that these companies are facing. They can't shift stuff around easily without like changing their entire architecture and all that, and picking up new tools, re-educating their developers, to use containers and stuff like that. And so that is the mission that we set out to solve with the Serverless Container Framework. It's like, great, everything you know and love about serverless, and then you could just easily move stuff around without re-architecting. So that is the goal, starting with just AWS Lambda and AWS ECS Fargate. So that is like the one thing people want to move between the most so far. So that's our laser focus is on that at the moment. In the future, everything. Google Cloud Run, Azure Container Instances, EKS, I dare say it, but we want to give people total flexibility here and give them a simple solution without embracing all of Kubernetes, right? To have all that. So anyway, that's kind of the context going into Serverless Container Framework.
And I think that's awesome. And Alan, if I remember, I can't remember when, but you posted an article a while ago, maybe it was the beginning of last year, where you talked about like adapting infrastructures, right? And this is kind of going into that, right? So if you're making infrastructure as easy to switch, right, between Lambda and ECS, potentially Kubernetes, or even a completely different cloud provider, and you can create these self-adapting infrastructures on top of it where, hey, based on the load, right, you're switching into, hey, based on the analysis, maybe with some AI models and stuff, you can see, hey, this would be cheaper to run in Google, right? And you just flip the switch, right? So we're getting there. I think closer to that type of adaptability, I might say.
Yeah, level of abstraction is, I think, the term I was using back. I think that was in 2023 when I said that, as like the forward look, where we think of things as very high level abstractions. This is compute. This is data. This is, you know, an API, and beyond that, the details should be handled for me by people that know these types of things better than I do. It's me being, you know, wish listing, being lazy.
Or AI, right? I mean, that's kind of that's what it's coming to, and that's another reason why we got into this and why we built it a certain way, is that you know, you can have humans managing where workload should go, you know, but pretty much now it's not even a future scenario anymore. Now you could also consider having AI move stuff around, as long as the tool is actually made accessible to agents and stuff like that, which is a whole other conversation topic we're getting into. But yeah, all these ideas are valid and absolutely the way forward.
That's great. Yeah, so you kind of explained the why on this, right? The serverless container framework, kind of following a different path, right? In some ways, but right now, like you said, and I know we've talked before, but it's the something tangible for that everybody uses are APIs, right? So you started with that. It seems like the great way to start and delivering these containers. Well, I guess you could do anything, but it's doing it via a load balancer, right? So more tied to a little bit of an API. But do you have a sort of, or can you share sort of the vision around the growth, right? We've talked about different cloud providers and all that, but where is this going, right? As far as what I can create using the serverless container framework.
Yeah, so we'll dig into a demo shortly, and let's get something deployed, because this is one of those great tools where it's just, we just have to show it, and I think it kind of speaks for itself.
Cool.
You know, but yeah, where is this going? You know, where are we at right now? First, we're just trying to solve the problem let's shift between AWS Lambda and ECS Fargate. Right? There's just so many. The day we launched this, we had massive companies emailing us saying, we want to use this right now. And the savings that they were talking about was hundreds of thousands of dollars, so annually. So they're just like, this is a no-brainer. Let's just, you know, we want to use this right away. So it's been fun. It's been a race to make sure that we're ready for these massive workloads. But you know, as a tool maker, it's wonderful to be able to have this situation where these like high volume workloads are going to stress test, you know, the new tool, which is wonderful. So, you know, right now it's just switching between Lambda, ECS, Fargate. There's a lot of EKS Fargate requests out there. You know, and then now moving to other clouds, I'm not sure, you know, the multi-cloud scenario, typically like migrating stuff across clouds, I don't see it as being very common. You know, typically I think we're going to see more people migrate between compute on a single cloud vendor, or they just want their developers to have one experience to deploy anywhere without having to like relearn everything, you know, which is really valuable. So absolutely, we will make deploying to these other clouds easier with the same experience. So you don't have to be a cloud platform expert, whatever the cloud platform is. And then, you know, right now we're just tackling the API use case. So there's the whole like Lambda. I mean, Lambda, you can do everything with Lambda these days. It's fantastic. And if that's what you want to do, use Lambda for all types of use cases. Serverless Framework, you know, traditional Serverless Framework is still a great option for that. Right now, Serverless Container Framework just focuses on API use cases. So it's just, instead of just deploying your containers, it's actually going to set up a full API. And so it's going to set up AWS ALB, it's going to set up the networking components, VPC, and it's going to set up your containers to connect to AWS ALB in a way that you could actually have ALB paths point to a Lambda function, and some ALB paths pointing to a Fargate service, ECS service on Fargate. So you can mix and match. And the beauty of like controlling the whole architecture when we deploy it is we could actually do zero downtime migrations also with the deployment. So already you can see that I think the theme is just flexibility. And whenever I think about building tools or like making anything, I'm always trying to find out what the theme is and work kind of from the inside out, you know, based on that. And so, you know, our team, we're just trying to figure out like, okay, how do we make this the most flexible option? what does that look like? Well, we should deploy a whole architecture. It's not just about deploying containers, but a whole architecture, and allow you to do cool things like switching out, the services between compute with zero downtime, or mixing the types of services or the types of compute in that architecture. So we'll show that off in a few minutes, I think.
Cool. Yeah. So I'm usually one to be skeptical of flexibility, because the more flexibility you give people, the more wrong things are going to do. But in this case, as we've grown in this serverless culture, not everything, your API will not be solved with just Lambda functions. You might have that one endpoint that you need to tackle differently. So being able to combine those, and that flexibility, I am definitely in favor of. So really love that. So should we take it for a spin?
Yeah, let's see it.
Yeah, I'm excited. Again, given the circumstances on my power outage, Austen will be showing this for us, but it'll be just like if I was typing. So make sure to misspell a lot of words and do stuff like that.
Yeah, so I'm winging a demo here, and as is typical when winging a demo, I have not given StreamYard permissions to share my screen, so I might have to log out and rejoin real quick.
Yep, that's all right. I'm curious while that happens, Andres, describe this like desert tornado that you're going through right now, or desert hurricane.
Real quick, guys, can you see my screen right now?
I can see it in the staging area. Let's bring it up.
Yeah.
Okay.
Yeah, we can see GitHub.
Cool.
All right, we'll pause on the desert hurricane. This is more interesting than a desert hurricane.
We'll see. Well, cool. This is that's great when things are easy like that. So hopefully the font size and everything is pretty good. But this is the Serverless Containers repo. So the Serverless Container Framework actually ships within the Serverless Framework CLI. And so we don't have to download any other tools. It's just in there by default. It just has a separate configuration file. Now we've set up this repository just for example projects. And so there's a bunch of example projects in here. The great thing about containers is, like anything you can deploy in containers, you could deploy with this, right? I think some of the the veteran AWS Lambda users, historically we've had to do so many hacks and things to get stuff working in AWS Lambda. But when you are just running containers in Lambda, things just get a lot simpler. Runtimes, et cetera, et cetera. So we've already launched a bunch of examples, have a lot more coming, of course. And the first thing to see here is the separate configuration file. So this is the first big value add. Use AWS Lambda, use Fargate ECS to deploy API without having to embrace different tools, without having to even change your configuration. And so I don't know about you guys, but what I'm actually not an advanced container user. In fact, I might have built my own whole company to avoid using containers, to be honest. And it's so interesting coming back around this way, for good reasons, though. Some of which I already outlined. But basically, a lot of people who are coming to this from the serverless world don't have a lot of experience with containers. They don't have a lot of experience with ECS even, and they don't want to learn it as much. And honestly, neither do I. So, but this makes that very easy. You don't have to be an ECS expert or Fargate. Understand how Fargate particularly works and all that stuff. You can deploy your API. You simply just list your containers here, point to the source code. This will, you can have a Docker file in there, or it will look at your source code and try to containerize it for you using build packs. So again, we want this project to be, you don't have to know a lot about containers. You don't have to know a lot about ECS, for example, or even Lambda. We're going to try and hide that. I think there's the infamous node engineer, TJ Holloway-Chuck. He had that great quote when Lambda came out. He's like, people don't really want to think about containers. They just want to think about logic and results. And that is like still near and dear to our hearts over at Serverless Inc. in terms of what we build. So, you can have a Docker file, or you don't need to have a Docker file. We'll try and auto-containerize it for you using something called build packs, originally built by Heroku, which just looks at package.json and stuff like that to auto-containerize things. Anyway, so you just point to your source code here, set up your routing pattern. This is just a wildcard path, so anything will kind of work here. Environment variables, and then compute type. And this is kind of where the magic is. If you want to switch from Lambda to AWS ECS on Fargate, you just swap this out, this one property, right? And that's it. You've done the migration, and I'll show that off here in this example. So hopefully you all can see this. I'm going to try and make things a little bit bigger. I'm going to open up that configuration file. So what is this example, by the way? This is your canonical AI streaming chat interface, ChatGPT clone, right? This is what everybody's building, right now. And I think it's a pretty good use case. It's a single container that does full stack. It has the backend API for reaching out to OpenAI, even Anthropic as well, and a front end chat interface. So you get the full stack, all powered, in one container. Of course, you get as many containers as you want in here. But this is it. This is like the minimum to get up and running. And I have the serverless framework installed already, so I'm going to run a serverless deploy. Again, no demo prep, so there's my obligatory disclaimer. Just kind of winging it. But
it's what we do. That's what we do in this live stream.
That is what we do.
It's
we're
minimal
pretty good
preparation.
at killing time for deployments.
Yeah.
That's all. That's the whole time it took.
Well, no, I forgot. I had already deployed this
see.
earlier, and so okay, so this brings up something really cool. The questions around like, well, why don't you just use Terraform for this? Why don't you use CDK, something like that, all that. And those are great solutions. There's a lot of great infrastructure as code projects out there. Now, our perspective on those is that they're going to give you a bunch of pieces, and you still have to build your own deployment experience. Like if you want to recreate this, you're actually going to have to do a lot of work because this container framework does a lot more automation than just deploy and remove. So our whole mission is we don't want to create another Terraform at our company. We simply want to find the mission critical use cases and come out with exceptional user experiences for that do a lot more than just your classic deploy and remove. Serverless Framework did that for building architectures on Lambda. Serverless Container Framework does that as well. So some examples of that are this will actually do change detection, smart change detection across one or multiple containers here. And it'll detect if there's been any changes in the configuration or in your code. And it'll skip the deployments based on that, essentially. So out of the box, you can have your mono repo and have a whole bunch of folders, each with different containers in it, and just have one serverless.containers.yml. This will automatically check what changed or what didn't change.
I like that smart detection, right? Because yes, like you said, we can do it. And I've seen people do that monorepo path with GitHub workflows and the filter path for when changes on this folder happen. And then that eventually becomes an array that has everything. And basically you end up deploying everything every single time.
Yes.
So there's some misuse there. So having that auto detected by the tool, a lot better, in my opinion, to reduce the work I have to do, right? Because as we've established, I'm lazy. So having it just taken care of, super valuable. And well, the tool will make sure it's just that piece, that container that needs to just deploy the image. Or I don't know if you can specify memory or anything there in that compute, but
Yep.
hey, I changed that. So it knows it's just going to have to update the infrastructure for ECS versus deploy my image again, right? So knowing those differences automatically super valuable.
Especially if you're deploying containers, because these are much bigger, these are much heavier, right? And then if you're deploying to ECS, it takes a while. Like, unfortunately, these are slow deployments. We've done a lot to optimize that as much as possible. We're about to launch a new version of this that finally does parallel deployments. And that's going to be amazing. But out of the box, these deployments can take longer than traditionally deploying just a Lambda or something like that. So the change detection helps. We've tried to really stress the details here. So, we give you like the essential minimal information. We have a debug mode where you can see everything, but we give you the essential, like, hey, no changes detected, or here, no changes detected, but proceeding with deployment due to the force flag. So I just ran another deployment. I hit force. So again, like, we don't want to build another Terraform. We just want to go after the mission critical use cases like your business logic and offer like really good experiences for that with a lot of attention to detail. And that's what you'll see in this project. And if any of you have experience with just deploying to AWS ECS in the first place, I don't know, Alan, Andres, have you guys used ECS much?
I've been using it more lately.
Like once or twice, like literally once or twice.
Yeah.
Yeah, I have more recent usage there, and yeah, the deployments take a while. And if you somehow messed up the health check or something, it's gonna keep hanging there for 5 minutes.
Right.
And you might not get the logs because it hasn't gotten to that point, right? So it's not simple. Then if you're doing like ECR, you have to have the right permissions on ECS to be able to get the image. I don't see any of that having to be set here, right? And I don't know if you've optimized that process. I know you're not using CloudFormation for this. So is it faster, right? Or if you miss the health check, will it still hang a little bit until it finishes the ECS service deployment? Do you know, right? So how are you doing? I don't know how you're doing that technically in the background, but is it faster?
If I might translate for you, because everything you said, absolutely true. These are real pain points. Deploying AWS ECS, it kind of sucks, right? There's just a bunch of ways things can go wrong, and there's no clear way of knowing what the heck happened. That always results in you having to do a scavenger hunt on the account, right? It's very, very frustrating. There's just a lot of ways things can go wrong. So in Container Framework, we could try and show this off later. We do our best when things go wrong to actually do the scavenger hunt for you and find that, right? And we actually pull the logs when something deploys and fails. We'll try and pull logs automatically for you. Just building the container, we'll try and pull logs, and we show them selectively depending on what the error is, if you actually need those logs, right? We only want to show you what you need to know in order to solve the issue. We'll get into that in a bit, but yeah, we've optimized this every which way to help you deploy to ECS without the pain. So
I love it.
So I want to throw out here, while we're at this point, this feels so far a lot like App Runner, with the big plus that favoring you that you can choose to run this on Lambda or ECS. App Runner, you don't get a choice. Did you get any inspiration from App Runner? Because like even the config file looks pretty similar to me.
Yeah, we didn't. We looked at App Runner a little bit. What were there were some real constraints with App Runner. I mean, we could support it, and certainly a lot of what App Runner is trying to do. I think what the Lambda team has been trying to do this whole time has been trying to figure out a good way to offer this flexibility. And I think we've probably seen a lot of their presentations, over the years in terms of, how they want to do that. And App Runner was supposed to be this great step in, this kind of interim ground between like Fargate and Lambda and whatnot. We definitely took, I think we ended up on the same path as App Runner. We didn't actually end up implementing it, although we still might, because we ran into some architectural issues with App Runner. We felt like, we could just offer this App Runner like experience without added cost, directly on Fargate ECS. And so we're not sure if we want to support it yet. We're still looking into it. Certainly an option for us. I can't remember off the top of my head what some of the pain points were with App Runner, but basically the insight was for us, like, we'll just build the same experience on ECS, give you the cost savings and all that without the additional App Runner cost.
Awesome. Awesome. One of the biggest pain points for me with App Runner is that it can only support HTTP connections in and out of it. Like you can't use gRPC, can't use RTMP through it, and it only supports one active port as well.
What's App Runner using behind the scenes? Is it ALB? Do we know?
I don't. I think yes. I think, but I'm not. Yeah. I don't want to be quoted on that.
Yeah, we also want to plug into people's existing resources. So Serverless Container Framework for us is like, you should be able to use this with your existing application load balancer and stuff like that. So it was easier to just build on these pieces rather than the abstraction that App Runner offered out of the box.
I just want to make sure, does that mean you can hook up multiple of these containers to the same API? Like I can just have different routes go to different containers?
Yep, that's what this is.
URL?
Yeah, that's what this is essentially. So this is deploying an AWS API, which is an ALB architecture with paths pointed. So here are the containers, and here's my first container. It's just called service. There's only one container in this config file, and here's the path pattern for that. So you can easily add in more containers, add in like 20, pointing at different paths. It's all going to use the same ALB. And of course, you could have some running on ECS, Fargate, and some running on Lambda.
Well, that is very cool. I love that. I love that. What a great idea.
Yeah.
One container per endpoint. Well, that's kind of what we do with Lambda.
Yeah. So here we go. I was trying to load it in an incognito window, but I was getting some weird SSL error because I'm just using the ALB endpoint, and it's, it doesn't have a SSL certificate out of the box. This does have full custom domain support. It'll connect your Route 53 domain hosted zone to ALB, set up the SSL certificates via AWS ACM. It just does that for you out of the box automatically. But yeah, here's your classic ChatGPT interface interacting with OpenAI. I don't know. We quickly just added in a bunch of models here. Here's Sonnet 3.7, and it's just interacting with both these.
That's really fast. It's interacting really fast.
Yeah, because it's doing those requests over to the model providers as well. So, and then under the hood, it's just your classic Express app, and we've got serving static files. So it's serving the front end, and it hooks up the routes here, which is just a simple, looks like API chat route. So it's your classic full stack front end, back end. The environment variables for the model vendors are just loaded here in the configuration. If you don't know about this in Serverless Framework, we have like one of the killer features is resolvers, which is basically the ability to fetch data from anywhere. So this is like you have to have. I've got a .env file right here that has these, and so it's just fetching from that. But you could specify AWS SSM. You could specify S3. You could specify Terraform state outputs. So a ton of people use our tools with Terraform. And if you want to use Terraform to provision databases, all that stuff, that's great, and inherit them here. You could reference Terraform state directly. And we have a bunch of options for referencing if it's in Terraform's cloud offering or S3. You could fetch secrets from Vault in here. CloudFormation outputs, of course, like it's variables are like incredibly powerful. So this is just fetching, from a .env file, and then here you'll see, where we basically called OpenAI SDK or Anthropic, and the front end actually sends up which model to use. So we just add in the model right there, and this is actually a streaming. So this is a streaming interface. Now, jumping into the drawbacks, every architecture, everything has trade-offs, right? One challenge when using ALB with AWS Lambda is that they don't have streaming support, right? For whatever reason, ALB is waiting for Lambda to finish entirely before it sends a response back. So we're high hopes that this is changing in ALB, but that's just one of those classic examples where you want flexibility not just for cost optimization, but also for functionality for features too as well, which is like we get that request as much as we get the flexibility request for reducing cost. So, but by default, this is on Lambda, and there's no streaming here as a result. So what would happen if we said, okay, well, we want to switch this over to Fargate and then run another deployment here. And so I'm not going to use the force flag because this should detect that I've just done a major change, which is like, let's switch out the whole compute service that's powering this thing.
It doesn't seem as major with what you just did, but
yeah. So here we go. Compute type changed.
One word.
New AWS Fargate ECS, previous AWS Lambda, performing zero downtime migration. So here it is doing a bunch of fancy stuff behind the scenes. It is basically this is running ALB still pointing to Lambda and whatnot. And it is going to go behind the scenes and it's going to set up the Fargate service. And it's going to perform the health checks on the Fargate service to make sure it's working accordingly. It's also going to set up a ALB route that is the same as this one, but it's going to deprioritize that ALB route so that still the Lambda one is actually still pointing to Lambda. But as soon as the health checks pass on the Fargate service, it's going to swap the priorities on that ALB path instantly. So you have basically a zero downtime deployment. So it's all happening behind the scenes. You can see there's a health check path you want to specify here. By default, you don't have to specify it. We will just look at the root path. And but we do recommend you set up a separate health check endpoint, just in case. So it's actually, as it deploys, the Fargate service here, it is, it's pinging that health check right now. So we've done
that it was updating the listener rule. So
nice. Right at the end there. So let's try reloading this. So we do have environment variables that we set automatically in the service too that tells you what compute it's on. I should have set up a demo where you could see what the compute service is behind the scenes. But that Lambda function is out. This is running, compute AWS Fargate ECS is what's powering this now. And I don't know if you saw that, but it's streamed in for the first time. So respond with 2 random paragraphs. So there we have the classic ChatGPT streaming. And I mean, that was it. We just switched over from Lambda to Fargate ECS. And we now have your classic streaming interface here, for building this out. And it was, hopefully extremely painless.
I'd say that was painless. That was really cool. I just have to trust you that that's what happened because you've abstracted so much out of the way. It's really, I'm just looking at these console logs. It's like, yep, that's all I got. That's easy enough.
Yeah, if you set really debug, cool. you'll see a lot more. By default, though, it's our principle is only show the user kind of what they really need to see. When they need to see it. If something went wrong here, I mean, we should try breaking the health check endpoint, for example, soon here. The problem with that is it takes a while to check the health check endpoints so we could be waiting for 5 minutes. Although I think we have a log that actually says something feels like it's not right already, and we try and show that earlier because we had users who are like, this takes forever. We're using it, and it takes forever. One of the problems with AWS ECS, one of many when you're deploying, is it not only gives you random feedback or not much feedback when things fail, and there's a lot of ways they can fail, but it takes forever to fail. So we try and show that log message when we kind of sense that something is going wrong, just to give you heads up before it officially fails.
And if it eventually does fail, right? Will it roll back, right? Your typical rollback to the previous resources and just, hey, go fix this.
Yeah, we do rolling deployments, by default with rollback setup as well. So it'll automatically roll back. Our log messages make a point of telling you that like this is going to be a zero interruption failure, where things will be rolled back in a couple minutes. That's actually ECS that's doing that rollback. It's not us. It's just a feature within EDS with that ECS with that deployment type. But we let people know, because that's the other thing. When something fails, it's like, what happened to my service? Like what's the overall impact? We let them know, hey, this is not gonna affect anything.
I can see
Pretty
this
impressed
getting
with the simplicity.
really. It is, and there's just so much that you can do with it. And we kind of talked about it a little bit already, but like I see this growing very quickly to a point where you don't have to specify that compute unless you want to.
Right.
With all the monitoring and the observability that we have, it would be very easy to watch the amount of traffic that's coming into an endpoint or a set of endpoints on an API and figure out where that cost saving is. Does it make sense that maybe overnight, maybe I have a very steady flow of traffic from 9 to 5, and then after that it just trickles. Maybe it makes sense to put that blue-green deployment on it at 5 p.m. and switch back to Lambda, and then at 8 in the morning, switch it over to ECS. Just kind of, I'm ready to go. It looks like you've already done some of the homework here.
Yeah. Being a tool maker for a long time, it's one thing to have a fancy tool, but you got to come with a business case as well, right? If you really want to give people as much information as necessary in order to make the right decision, it's like offer killer UX, that solves a real pain point, and then like show off the business case here. So here's kind of a rough back of the napkin, math on like what the break-even points look like. So for this exact use case that I just showed, that was like a 1 gigabyte Lambda function that typically runs for like 200 milliseconds API. And so you compare that with a 1 gigabyte provision ECS Fargate task with 0.25 virtual CPU. And so the question is like, what's the break-even point? Well, of course, AWS Lambda scales down to 0, right? So that is one big benefit. You could recreate that with Fargate, but it's probably not a good idea. You'll have long cold starts, so you have to do scheduling stuff yourself. But with Lambda here, I mean, for this API use case, what we just showed off, roughly, approximately, I think the break-even point is between 3 and 5 million monthly requests. So if you're hitting 3 to 5 million monthly requests, that is the time to switch over. Which is actually, when we were doing this, it was sooner than I thought. I thought you'd have a lot more room to go on Lambda, but it's really not the case. And so at 5 million, you're paying about $17 in Lambda, and then about $18 for ECS. But the interesting thing, of course, is how it scales here. So you could see, how the numbers change significantly as you go up. And I'm pretty sure we ran this scenario with the reserved, like a compute savings plan discount as well built in. So you get some of that, with Lambda. You get a lot of possible discount options, with ECS as well. So there's a lot of ways you can discount. This isn't even bringing in spot instances or anything else like that, which you could save 25, 35, maybe up to 50% more with those, which is next for us. But you can see how significant the price savings are. And this is why we kind of knew this, but we were still surprised when we had all these companies reach out. We need to switch right away. This will save us a ton of money, and it's been fun. But yeah, pretty astounding here.
Yeah, look at that 2 billion one is a hefty difference.
Yeah. We have many users doing billions and billions of monthly invocations. So ALB, now this one is not as significant. It is if you're still using API Gateway version 1. And so API Gateway version 1 still has a lot of features that version 2 doesn't have. But V2, they did do a good job on the cost savings. For a long time, you guys probably remember API Gateway was just, everybody was complaining about the price of version 1. Like it's just super expensive. So they came out with V2 that had tremendous cost savings here. And so you can see the difference is not so severe. It definitely, around like 1.5 billion, you'll start saving some more with ALB. But if you're using API Gateway version 2, right? But if you're using API Gateway version 1, the break-even point is probably like at 10 million API requests a month.
Yeah, and that's,
I mean, one limiting.
I think some people, sorry, real fast. Some people might not know the difference between V1 and V2. That's not how I think about them in my head. Like I think V1 as the REST API one, and then V2 is the HTTP one. At least that's how I declare them when I'm writing something. I'm just trying to get
classic
the same
AWS
ubiquitous
naming confusion, in my opinion.
Yeah.
Yep.
Yes.
Yeah, what I was going to say is one of the limiting pieces, right? Because you're using ECS, you can't route directly from API Gateway, right?
Yeah. So there's ways of doing it. They all looked a little janky. And there was people talking about scaling issues as well. And I was like, this project in particular, this is for people who are okay to spending a minimum amount. They're not really looking to scale to zero, right? Like if you just embrace pure Lambda and pure serverless services, if that's the quality you're looking for. But we wanted to build something that's really designed for large companies who don't really care as much about scaling to zero. They have already enterprise agreements with AWS where they commit to spending a lot of money already. And so we are designing this project, for with them in mind. And this thing has got to scale, right? This thing, has to really scale up. So we are using, tried and true infrastructure here and patterns in order to do that. So hence ALB.
Yeah, I think if they're doing 1 million, they can take on the $25 ALB cost at that point.
Yeah. For those who are curious, I think for one of these Fargate task provision, with these configuration options, you're looking at an $8 bare minimum for that one task running, which you could probably handle a lot of requests a month. Tens of millions, basically. Our rough math shows between 50 and 100 million requests a month. Like you're going to want to hit two tasks. For this use case, everything is different. But if you just want the bare minimum, you're looking at $8 for that Fargate task, $16 for ALB. So that's your hourly rate plus like one load balancer capacity, and I can't remember what the LCU stands for.
Yeah.
So $24, a month with this architecture at the bare minimum.
That'll get you pretty far too. That many millions of requests a month, that'll get you real far.
Yeah, I mean, it's not a bad deal. Something we also did, when we were designing this, this is simple configuration. If you look at our docs, it gets very advanced. You could do all types of scaling modes with Fargate and stuff in here, and custom domains, of course. You just put in domain here, and you could actually have multiple domains. You could have different domains on each container, and they'll all be hooked up to the same ALB and API. And the reason why we wanted to really have this, again, flexibility is the theme, right? But we thought like, what if we just made one architecture that you could run your entire company off, right? You don't need to spin up all these different stacks and stuff. Like every company has a bunch of domains, subdomains, all these different projects and stuff like that. Like let's just make one architecture where you could have a bunch of different domains set up to it and have like, total flexible path routing, thanks to ALB. And so this is, our goal is like, hey, can we run our entire company off one configuration file here?
I bet those were fun design meetings, fun whiteboarding sessions.
Yeah. Well, it just takes 10 years of building up scar tissue, and then they're fun. So real quick, by the way, just to jump into the development experience with this, because serverless has had a notorious development pain point. Like building serverless apps has always been really hard. And the reason is you either have to emulate all of AWS locally and try and keep that working across a growing project and a growing team. And it's like this tax that increases every month. Or you have to deploy every change to AWS, which is slow. So you're just waiting for CloudFormation deployments, all that stuff. It's just slow. So hybrid approaches have been coming out lately, like basically having your Lambda function, your live Lambda function, forward the event down locally, and you could run that against local code and make changes really quickly because you don't have to deploy everything. See errors, see logs really quickly. You don't have to go into CloudWatch because it's running locally. And then forward the response back up to that same Lambda function, and the Lambda function responds with it. So this is the hybrid approach. We have that in Serverless Framework. It's just called dev mode in classic Serverless Framework projects. It's great, but there are still some challenges here if you're working in a shared environment and somebody intercepts a Lambda function. And because someone is working on a Lambda function in that dev environment, and then perhaps they go to lunch and they shut their computer real quick, and that live Lambda function in the dev API is reaching out to their computer, which they just closed. There's some blocking issues with that type of development experience. So with the container framework, we're like, well, we've got containers as a first essential concept here. Like we could have really good local emulation, right, out of the box. And in addition to that, we are deploying an architecture, not just the containers, because we're deploying ALB, stuff like that. So we thought, like, let's go back to local, and let's just offer out of the box really good emulation of Fargate or Lambda in the container, running locally, and out of the box ALB emulation. That's really good. So when you run serverless dev, we're going to set up one container runs locally with ALB emulation, and you can interact with that via localhost. And then that's going to forward requests to another container that's spun up for each container that you have listed here. So it'll spin up one or many of these containers, and you just get localhost out of the box. And so, without having to go through all that deployment stuff like that, we have our same, our same app running locally here, right? So this is, you don't have to deploy anything. You could just run this locally, just run serverless dev. We're going to give you great logs out of the box, like just showing you what API requests are hitting your API locally, so you don't have to log all this stuff, what the methods are, what the paths are that are hit. And of course, you could just update. Let's see, what should I do here? Your log stuff shows in here as well. Oh, we have hot module reloading too.
Nice.
So on changes, we will do a couple things. If you have a Docker file, we'll just rebuild the container for you real quick. If you are not using a container and we're containerizing it for you, we actually have really good hot module reloading in that case for Node.js and I think it's just Node.js at the moment. But we're spinning up a Node.js container and doing cool hot module reloading that's very instant out of the box. So we'll try this again, and there's the hello world log. So if we want to break stuff, I'm going to save it. It's reloaded. I don't know what our error experience is on this example app. I don't think we have any. But there you go. You've got your error out of the box, the stack trace, no going to CloudWatch or anything like that. And then the thing we're shipping, we're trying to get this out with the GA release, or the initial release, I mean, is the ability to only have localhost, only selectively run one container locally or two containers locally. And then when you use localhost, it'll either intercept the ones you selected to run locally, it'll intercept those, direct those to local containers. The rest will go to live containers running in a specific stage, aka environment.
Oh,
right?
Yeah,
that's cool.
So this goes back to solving the problem of, that the other hybrid approaches, they'll intercept a shared Lambda function and like break it for everybody using that shared dev stage. But now you could just intercept things locally. You could still have this pointed to your dev stage and just say, well, I'm working on the user's container, right? And it handles all user auth or something like that. So I just want localhost. When I have localhost on my machine, it's just going to interact with that container locally. Everything else will be proxied up to the live environment. So this solves the problem of now multiple people can work on that service without breaking the shared dev environment for everybody. And this feels like I think we finally got it right for serverless development. The emulation out of the box, by the way, it'll inject you could deploy an IAM role for each container, just add AWS IAM, and it'll inject the credentials for that in the container as well, if that's deployed. So you have the permissions emulation out of the box. So long way of going back to why not just use Terraform to build this yourself? And our point is, well, you don't want to build all this stuff yourself. We poured incredible attention to detail into this. The world is moving way too fast to try and bother building that stuff yourself at this point. And we're going to try and knock it out of the park for you here, with this. And these are all the ways that we're doing that, going above and beyond just deploy and remove, which is like classic infrastructure as code.
So I really, really like what you're going for with that, with the emulation and then just running the single container.
Yeah.
Because, what you see typically, right, and what people are used to is just running everything, right? So I have 10 containers. I'm going to have a massive Docker Compose file that's going to run those 10 containers on my machine. And now you need a bigger machine, right? Instead of just running, hey, I'm just working on the user service, I just want to run that one against something that's already deployed. And
right.
Having that done automatically, I love it.
Plus ALB emulation. It's not just about running the container locally. You have to emulate where it's going to be running, right? And how it's going to be, hit. And even we'll do all the Lambda, you have to put extra stuff in Lambda, like the web adapter and things in the container to get containers to work on Lambda. We do all that behind the scenes as well. So even if you don't have a Docker file. So it's not just about spinning up the container locally. It's about the architecture, locally as well.
And is serverless taking care of the actual, do I need Docker running, right? Is it using Docker in the background, or are you taking care of just running the container in your framework, basically, in your CLI?
This does require Docker right now. I think we have the Podman. I think the Podman PR is definitely ready. We just have to look at it. It's probably me. I'm usually the blocker. So that should be probably arriving next week, and we'll support all the various ways of running containers. But right now it's just Docker support.
Cool.
Seems like a good one to start with.
Yeah, I would think so.
Yeah.
Cool. This is very good stuff.
Yeah.
Because I tried the development piece, but with Lambda, right? With what you're talking about, that is actually deploying a change in the Lambda function in the cloud to proxy to my local. So that's disruptive if you're sharing environments. There's obviously a path forward with isolated environments for developers. That's a long post. But yeah, so yeah, I think I forgot.
Oh, the CloudFormation question.
Oh,
so let's see.
We can't see you now, Austen. With a,
I know.
Well, let's get the gist of the question, and we can bring Austen back.
Yeah. So one query when a test deployed
like and subscribe.
Yeah. So what is it thinking? Or would it elements be added to CSI? Forgive me. So talking about the change that this is not using CloudFormation.
Yep.
And I think with the concept of sharing the existing resources, right? If you already have an ALB, how would that play together?
Yeah. Okay, so this does not use CloudFormation like traditional serverless framework does behind the scenes. So we're not using CloudFormation because it's hard to offer this level of experience when you use CloudFormation. All the fancy stuff we're doing is just things we couldn't do with CloudFormation at the end of the day. And I know this is somewhat controversial. It seems less controversial these days. I mean, 5 years ago, if we said we weren't using CloudFormation anymore, I don't know. It's weird because Serverless Framework grew to prominence without being a CloudFormation tool in the early days. And in some ways, the experience was better with like version 0. I still look back at that first version. And I'm thinking like that was a great version. And then we embraced CloudFormation later on. So it's interesting to know that like the project got so popular without CloudFormation, then we embraced CloudFormation. And now, with this, we're not using CloudFormation because it's just too hard to offer this level of experience with CloudFormation. So then the questions arise of like, well, CloudFormation is battle hardened and like, well tested. How does this compare? How do you beat CloudFormation in that regard? And the answer is pretty simple. It's because CloudFormation is trying to deploy everything. Terraform trying to deploy everything. And it's actually really hard to do that well. CloudFormation does a great job here. But we're just trying to deploy specific things. And when you have a specific goal, it's much easier to deploy stuff more reliably and more quickly because you know what you need to do exactly. And you know what the possible failure scenarios are along the way. And you know what you could run concurrently when you do that as well. So as long as you have a narrow focus and you're not trying to do every possible combination of everything, you could actually provide a faster, more reliable tool, which is what we do. Like I haven't shown it off, but when ECS deployments are failing, we're just so good at detecting something going wrong initially, informing the user, hey, this is what we think is happening right now. It's not going to affect anything. And doing that much more quickly than CloudFormation. So you'll see like the deployments are pretty fast already. We're doing a lot of parallel work in AWS calls. But yeah, it's all about having the narrow focus first and foremost. If it's classic, like narrow the focus, increase the quality, like product mantra. And so that's what we're doing here. That's how we're able to pull this off reliably, all that. The other reason why we're not using CloudFormation is because of some things we want to do in this new AI era. And so we are taking the position of, okay, humans use our tools, but agents need to use our tools in the future as well. So we use a lot of agents at our company. We're recent Devon subscribers. It's freaking amazing. And it's definitely changed our thinking in terms of like, okay, we build tools for humans and agents now. And what do we need in order to do that? So we have a lot of forward-thinking ideas we haven't launched yet in terms of how AI agents will use Serverless Container Framework. But that stuff is coming. And we needed to have basically a rich utility library that AI agents can work with to do various deployment stuff rather than just rely on CloudFormation. So it's hard to talk about without showing off, what that product will look like. But it's one thing that's heavily on our minds right now. And I think every dev tool maker right now is thinking about, okay, humans need to use this, but these AI agents need to use it as well. What the heck does that mean? How do you design your tool for that? So we're doing the fun whiteboarding sessions on that right now as well.
That's awesome. Looking forward to that. We can do another one of these once we see some of that in the field. So we're out of time. But this was good. I'm liking it. I'm gonna play around with it a little bit more once my electricity's back. But once I get real Wi-Fi. So I'm not stuck waiting for an upload. But just recapping, I mean, we saw that simple change, which is the main feature, right? You changed like 10 characters and typed in
the killer thing.
Deploy.
And it took a lot to get there. Right?
A lot of explanation, awesome. a lot of history, right? So a lot of good stuff. And the deployment or the development experience seems to have a lot of potential and appeal to me on testing multiple microservices at the same time where there are different containers and just focusing on your own container. So I like what you're doing, and excited to see what's to come in the future. So good stuff. Any comments, Alan?
Yeah, no, the big takeaway for me is that it doesn't actually change the real development experience. It changes the developer experience a little bit as far as like what the configuration file is, but we didn't import anything special. We didn't write our code that's doing the business logic in a special way. It was the exact same as if I was writing it for Lambda versus writing it for ECS, which to me goes a really, really long way and takes
Yeah.
a firm, or I guess a big step in the direction that I think we need to go in tech and real serverless development. Is I'm just writing compute. I'm not writing for Lambda. I'm not writing for ECS. I'm writing my compute code, which is awesome. So cool to actually see it work like that.
That's such a good point. I mean, we've all been in the serverless community for a long time, and we know we've had to just do things very differently for serverless architectures and working with Lambda in the past. And I think it's caused a lot of organizations to not adopt serverless as much as they could have. I think we missed out on the container. It seems like orgs have mostly standardized on containerized workflows. 80% is that. And then the 20% is serverless, typically, when we go into a large org and we see what they're up to. Now, hopefully, we could merge these worlds, better than ever. We're just embracing tried and true containers. And so hopefully this is good for the serverless movement. Plus, the container performance on Lambda is like really good now. I mean, what was the insight, from the AWS team? It's like if your Lambda function is over 30 megabytes or 40 megabytes, it'll most of the time have less cold start than a zip file will. So due to some advanced container caching that they're doing. So that's another reason why it's like, okay, now it's time for serverless containers. Flexibility, like let's just write code one way, standardize with, what orgs are mostly doing. And now container performance on Lambda is really good. So yeah, all the reasons why this is a good time for something like this.
For sure.
Couldn't agree more.
Cool. Well,
right.
Thanks a lot, Austen. Alan, welcome back.
Thank you. Thank you.
This was a good stream. Got a good question, and I'm excited. So let's keep moving forward. Let's keep building serverless applications and keep innovating with all these cool new things that are coming up. So excited for this year. A lot of things already come up. So with that, I'll say goodbye to y'all. Have a good one.
All right. Thank you, everybody.
Thanks for having me, guys.